Hello everybody and welcome back. In this video we're taking a look at question 20 on our Pascal contest. In the diagram, square PQRS has a side length of 40. Points J, K, L, and M are on the sides of PQRS as shown, so that JQ is the same as KR, is the same as SL, is the same as MP, and these are all 10. Okay. Line segments JZ, KW, LX, MY are drawn parallel to the diagonals. So that W's on JZ, X is on K. Okay. What is the area of this quadrilateral in here? I would say by symmetry we can. It's clear that WXYZ should be a square. I'll see if we can prove that in any way, but oh yeah, that won't be hard to prove. So it's a square. It's just a sort of a question of what its side length is, really. So we got this. That's the rough idea. It doesn't have to be a fantastic picture. Anyways, because they're parallel to the diagonals, I know that this is 45 degrees and this is 45 degrees, but here I've got a nice little quadrilateral. Now, what are the sum of the angles inside a quadrilateral? Well, 360 degrees. Well, I've got a 90 here because it's the corner of a square. If this is 45, this must be 135 in order to get a full line. 45, 135 is 180. This 90 gives me 270. We must have a right angle here. So we get a right angle here, right angle here, right angle here, right angle here. So it's at least a rectangle. But by symmetry, you can see, okay, it's going to be a nice little square. Okay, so what can we do here? Well, really need a side length here. How could we possibly find the side length? I'm not missing any information, right? No, just have the 10 there. Because I know the side length is 40, I can get this 30 here. Okay. I'd really like to know this length x. That'd be good for me to know. So what can we do? I'm really tempted to say that, just split this in half and this should somehow be symmetric with this, but I don't think I can guarantee that. No, in fact, I'm pretty sure we can't. But I'll tell you what we can do. If we split this in half, knowing that I've got a 10 here and a 30 here, I can figure out this side here. It's going to be 10 root 10. Yeah, just use the Pythagorean theorem. 10 squared plus 30 squared. That's 100 plus 900 is 1,000. So this red line must be the square root of 1,000, which is also 10 root 10. Okay. So we got that. Where can we go from there, if anywhere? I mean, it's question 20, so it should be a little challenging, but I'm not seeing exactly where I want to go with this. Maybe that wasn't the way to. Maybe we want this angle here. Just extend this 45 here, because then I've got another right angle here, got another 45 here. And if this is 30, then this is 30. So then this bit in here must be 20. And so with an isosceles right angle triangle, if you've got the legs, again, you can use Pythagoras and you can see, oh, the hypotenuse should be y times root 2. So each of these is going to be 10 over root 2. Okay. And so that's the same length as it is up here, so 10 over root, or 20 over root 2. So 10 root 2, sorry. It's been a long day of recording. Each of these is 10 root 2, 10 root 2. But the total length should be 30 root 2. So 30 root 2 minus 2 copies of 10 root 2. X in here should be 10 root 2 as well. There we go. So I didn't need this red line at all. I was just a little stuck, didn't see the right thing to do. So we just extend those things that are parallel to the diagonal. Okay, so if x is 10 root 2, what's the area of this shaded square? Well, it's x squared, so 10 root 2 squared should be 200. And there we go. And 200, is that one of our answers? Absolutely it is. It's B. So that's what we're going to do. We bubble in B, and we move right along. Now, in the next video, we're going to be starting question number 21, and that'll be the start of part C of the contest. Each question is worth a little more. There's only 5 questions left. So, if you haven't already, I would strongly encourage you to give them a try before joining me for question 21 next time. Take care.